Hello, everybody. So today I will give you some example for how to understand and how to solve the problem in the exam. So some students told me that, Professor, I know how to perform all this t-test or the z-score test, but I feel the question is hard to understand, and I don't know which test I should use to solve the problem. So, okay, so today I will give you some example, and maybe it's helpful for you to solve the problem in exam 2. So, say I have 4 examples in total, and 1 for the z-score, 1 for the 1 sample t-test, 1 for the 2 sample t-test, and 1 for the paired sample t-test. So let's start with the first one. So here we have a problem like this, and let's try to learn how to quickly find the information you need to solve the question, right? So here we know we have 1 sample. This is the keywords, 1 sample. And then we have a population. We know its mean. And we know its standard deviation. And also we know the sample mean. The purpose is to compare the sample mean to the population mean. That means what we know is the 1 sample with treatment, the population without treatment. We know its mean and standard deviation. That means we are going to perform the z-score test. So what's the difference between these 2 questions, right? Most of the words, they are identical, exactly identical, but except these keywords. In the question 1, is that whether or not there's a significant effect. In the question 2, right, whether or not it's a significant improvement. So a significant effect is a non-directional question, but this one, whether or not it's a significant improvement, is a directional question. To solve the unidirectional question, right, we need to perform a 2-tailed test. But to solve a directional question, right, then we need to perform a 1-tailed test. And then we know for the question 1, we need to perform a 2-tailed z-score test. And for the question 2, we are going to perform a 1-tailed z-score test. And then let's start to solve the question. So we need to solve the question use the full 4 steps approach, right? As we learned in the class, we know the 4-step approach for hypothesis testing is consisted of these 4 steps, right? The first one is to state the hypothesis. So to state the hypothesis. If you check this slide, H0 for a 2-tailed z-score test, right? I have the summary here. So this is the H0. Means the population mean after treatment is equal to the population mean before treatment. And then we need to also write down H1, which is this. No, sorry, this means the population mean after treatment is not equal to the population mean before treatment, which means we do have a treatment effect. Okay, so we finished the step 1 to state the hypothesis, and then we need to do the step 2, which is to determine the critical region. So step 2, the critical region. To determine the critical region, right here, we know it's a z-score test. So it's only determined by the alpha and your direction of your hypothesis. So here we know alpha equals to 0.05, and it's a two-tailed test. So which means we need to the 5% is distributed equally distributed in two-tailed of the distribution. Means we have 0.05 in each tail, right? So then we need to use the uninormal table to search for the boundary. The critical region is Z. So it's if to search proportion in tail, which is 0.05, 0.025, here we can find this number with the Z-score as 1.96. So because it's a two-tailed test, so the critical region should be the Z smaller than the negative number and Z greater than the positive number. So we finish step 2. And then step 3, we need to compute the Z-score, right? So here we have the formula how to compute the Z-score. Chapter 8. We have this formula. Z is equals to m minus mu divided by the sigma m. But we know what, so here we know the m, which is 54, and we also know the mu, right, which is 50. But we don't know the sigma m, so we need to compute the sigma m first. So this sigma m here, we also have the formula. Which is equals to sigma divided by the square root of n. So here we know the sigma, right? We know this number, which is 16. And the square root of n we also know, which is also 16. So we can solve this one, which equals to 4. We know the sigma m equals to 4, and then, so put back in the formula. So we know that Z equals to positive 1. And we finish the step 3, and then we start step 4, which is make the decision. So because Z is equals to positive 1, and that means Z is between, right? These two boundaries means it's not located in the critical region. So we failed to reject H0. Means we don't have significant treatment effect. And that's it. We finished the 4-step approach. And also here, we need to compute the effect size. So for Z-score test, right, the effect size is the Cohen's d, estimated Cohen's d. So the estimated Cohen's d, we can use this formula. And minus mu and divide by sigma. So here we know the m, which is 54. And we know the mu, which is 50. We know the sigma, which is 60. So and then we know the coefficient is equals to 0.05. For the effect size, and then we need to write a sentence in APA format to report the result. So if you don't know, you need to go back to my slides for the chapter 8. But here I will show you an example. So the sentence should be participant who took the verb related, because this is the sample, right? This is our sample show. And because we failed to reject the 8-0, so they showed similar. And then similar, what's similar? The dependent, what we measured means the dependent variable performance in the memory test. Because they take a standard memory test. Okay, in the standardized memory test. So here we report m equals to 55, 54. Compare. So here we report sample, and then we need to compare to the general population. Mu equals to 50 and sigma equals to 16. And then we need to report z equals to the positive 1. The p, because it's not in the critical region, means p is greater than the alpha 0.05. And then we need to also report, because report coefficient d equals to 0.25. So that's it. We solved the first question. And then how about the next question, right? Means the one-tailed test. So it's a little bit different. For the one-tailed test, right, the hypothesis is different. Means the H1 means here we indicate H1 is in the treatment group where has showed significant improvement, right, in the scores. So means the population mean we hypothesize the population mean should higher than the original population mean. And for the H0, right, if should be is smaller or equals to the population mean. Similarly, the step 2. So we know the alpha equals to 0.05 is the same. But it is a one-tailed test. That means the 0.05 is on the entire one tail. So because we hypothesize the treatment, if is the population mean after treatment should be higher than the population mean before treatment. So means it's on the right, the critical region should on the right hand side of the distribution. Here's my table. Then we need to check the uninormal table. So proportion in tail, right? 0.05. we can just select this number, the critical region, z greater than 1.65. In step 3, we don't need to compute the z-score again because the z-score will not change. So we know the z equals to +1. And step 4, right? Because the z is smaller than the boundary, it means it's not in the critical region. It means we failed to reject H0 again. So here is easy to how to report your results. Just copy and paste the entire sentence. But here to revise some keywords, right? Show, because we have the direction in the question, so we need to answer whether or not it showed significant improvement. It did not show significant improvements. Did not significantly improve performance. And here, because I don't need you to compute the effect size, so you don't need to report the effect size. That's it. So the major difference is just you just need to revise several words, right? To answer the question 2. That's it. So here we finish the problem set for the for the z-score test. Okay, and then let's go to the next question. So here we have a very long question, and then let's take a quick look. Also here we have one sample. And also we have a general population. We know it's mean. But we don't know the standard deviation. And then we have a sample of scores. So because we have all scores, we can know the sample mean. So means what we know is a population mean and sample opportunity. But we don't know the population standard deviation. So to this kind of question, right, we need to conduct the one sample t-test. Okay, let's do the one sample t-test. So let's start with the question 1. So similarly, you can quickly read this question. Very similar, right? These two questions, just keywords, they are significant. So here, the keyword is significantly different, right? It's a non-directional question. But in question 2, so the question is significantly lower, means it's a directional question. Similarly, we need to perform a two-tailed test to solve the question 1. And then we need to conduct a one-tailed task to solve the question 2. That's it. That's it. So let's start with the 4-step approach. The step 1, right, to state the hypothesis. Very similar. And just copy and paste this line because the hypotheses are exactly the same. And let's start step 2. Determine the critical region. So here we know the alpha for a t-test, right? The critical region is determined on 3 factors. One is alpha. One is the degrees of freedom. Degrees of freedom equals to n minus 1, which is equals just to 12 minus 1 equals to 11. And the third factor, right, is the direction, because it's a 2-tailed test. So we have all of these 3 factors, and then we need to use the t-table. So let's search the line 11 and 2-tailed test 0.05. Okay, we find this number. Critical region which is equals to t smaller than negative 2.21 and t greater than positive 2.01. We finish step 2, and let's start step 3. We need step 3, right? We need to compute the t-score. So go to a 1-tailed test. How to compute the t-score? We need to use this formula. Here we need to compute, right, the population mean first. No, the sample mean first. So to compute the sample mean, to save time, right, I just use the Excel to compute the sample mean. In the exam, you can use the calculator to compute the sample mean. Just sum them together and then divide by the sample size. That's it. I assume everybody know how to compute the sample mean. Okay, the sample mean equals to 37 minus the population mean we know which is 40, but we don't know the SM, the standard error of the mean. Okay, how to compute the standard error of the mean? Here we need to compute which equals to the S squared minus N. Okay, we still don't know what's the S squared, right? So the S squared, if you go back to the previous chapter, and then you can know the S squared equals to SS divided by the degrees of freedom, and then divide by N. So that means we need to compute the SS. How to compute the SS? So if we go back to the previous chapter, so we have this formula. This is the computational formula, and both the definition formula and the computational formula for the SS. So here, because the mean is an integer. It's very easy to compute. That means we can use the definition formula, right, to compute the SS. So we use this formula. Okay, that means we need to compute the S sigma, so the sigma minus the x minus mu for every scores. That means we need to compute. You use the 38 minus 37. Use the 37 minus 37 because the mu equals to 37. Okay, to save the time, right? I just use the Excel formula. Do all this. In the exam, we don't have that many scores, right? You can compute it by hand or use your calculator. And then to compute this one, we need to compute the square of every score. Means the square of this one, right? And the square of 0, square of 4, something. And then we sum them together. We know it's 118. So we know which SS is 118. Y by degree of freedom. Here we know which is 11. And N rate is equals to 12. Use your calculator to solve this formula. So here, use your calculator to solve it, which equals to 0.095. And also, we also here put the 0.095 to here, and then use your calculator again to solve this one, which equals to negative 0.11. That's it, right? We finished the step 3. So let's start with step 4, how to make the decision. Because the t, it is smaller than the negative boundary, means it is in the located in the critical region. So we reject H0, means we have significant treatment effect. Okay, we finished the 4-step approach. And now I ask you to also compute, right, the effect size 3 indices, 3 measurement, the coherence d, the R square, and the 95 confidence intervals of the mu. Let's do it. The coherence d, we also have this formula. So here we don't know. Do we know the S? We don't know the S yet. So here we need to compute the S. S is the standard error, right? So if based on the chapter 1, S for a sample, S equals to the SS divided by n minus 1 and the square root of this one. So let's do the computation. We know the SS, no, okay. And also we know the n minus 1, which is 11. Use your calculator to solve it. You know S equals to 3.3. So here we have all of this information. We can do the computation. M equals to 3.3, which equals to negative 0.90. So that's it. We compute the coherence D, and then we compute the R square. Use this formula. So T we know, right? And then dF we know. Just solve it. T equals to, here we know the T value, negative square. Plus 11. And then use calculator, we know is about 0.80, 70. Okay, we finish this one. And then we also need to compute the 95 confidence interval. 95 confidence, 95 of U. Here is the formula. So M we know, which is M minus plus. T we also know. And then times SM we also know. Use your calculator to solve it. Let me tell you the answer. We have two numbers for the confidence interval. That's it. So, and then the last thing is to write a sentence in APA format to report the result. So okay, let's start to report the result. First part is our sample frequency mover. Right? It's our sample. Report it because our decision is we have a significant effect. So here is a significant different well-being levels of well-being. Well-being scores is what we measured right here. Well-being scores. And we could report the mean. Mean is equals to. And then we need to report the SD. SD we didn't. Oh, SD. The standard deviation. Or he's here. It's 3.3 compared to the general population. General population is our population before treatment. What's wrong? So here we report what we know is the population mean. Mu equals to 40. And then we report our statistic scores. T, parentheses, the degree of freedom, we equal to negative the T value because it's significant, right? Its P is smaller than the alpha value. And then also we compute the sample size. So we report the effect size. So we report the cohort C equals to report the cohort C first. And then next one is the R square. And then last one is the 95% confidence interval. So that's it. We have everything, right? We solve the question 1. And then let's start to solve the question 2. Actually, it should be very similar. The question 2, we just need to perform the one-tailed test. Here, the one-tailed test, so the hypothesis is a little bit different. We are assuming that the frequency mover has, whether or not it has significantly lower than the lower well-being scores. So the alternative hypothesis will be the mu after treatment should be lower than the mu before treatment. Therefore, for the non-hypothesis, it will be not significantly lower, means it should be greater or equal to the mean before treatment. And then let's start to determine where is the critical region. So here, we change to a one-tailed test. And also because our assumption is, our hypothesis is slower than the population mean before treatment. So it's on the left hand side, right? Go back to, where's my table? Where is my table? Oh, here. So let's check the frequency table. With alpha equals to 0.05, one-tailed, and then degree of freedom has 11. So should be this number. So we have our critical region defined. Okay, and then the step Step 4, we don't need to do any computation. We just copy and paste what we have here. T equals to negative 0.11. Because the T value is will be not determined by your question. And then let's do make the decision. So very similar. Here, the T is still, right, smaller than our boundary. So we also reject the H0. That's it. Okay, and then to go back to question, right? We do not need to compute effect size, so we are done. And then we just need to write a sentence in AP format. So the sentence will be very similar. Copy and paste here. Frequency mover reported significant, so not different. So here, because we know it's lower, well-being score comparisons. That's it. Oh. Means we successfully solve these two questions. So here, I hope you know how to solve the one sample t-test question, and you need to write down all of this information. That's what I did for the exam. Okay. Let's start the next question. Okay. So here we have a question. So let's take a quick look. Okay, we have the chaining group, right? And then we have a control group. That means we have two groups. We want to compare their mean. So we have different subject. Because we didn't say we have the same subject in different groups. So it means we have different subject in the two groups. That means we need to perform independent measures t-test. So here also we assume the two populations have equal variance. That means we don't need to test the homogeneity of variance just to save your time. Okay, so let's take a look at the questions. What's the difference between these two questions? So other parts are very similar, just this part are different. Significant difference, significant improvement. Similar, very similar as what we have in the previous questions. So means here, this is a two-tailed, we need to do a two-tailed test, right? And here, we need to do a one-tailed test. That's it. So we read this question, and then let's start to solve these problems. 4 steps approach. Step 1, state the hypothesis. Go back to my slides. For independent measures t-test. Right. The H0 should be U1 minus U2 equals to 0. And H1 should be not 0 equals to 0. That's it. Step 2, we are going to determine the critical region. To determine the critical region. So it's very similar. Just to save some time, I copy and paste this words. So we have alpha equals to 0.05. And then this in the two sample t-test, right? How to compute the degrees of freedom. So 2 sample t-test, degrees of freedom equals to n1 minus n2. N1 plus N2 minus 2. N1, we know it's 4 because we have 4 scores, right? N2, we also have 4 scores, minus 2. Which equals to 6. A two-test test. So we have all the information to determine the critical region. So use the T table. Okay, DF equals to 6, two-tailed 0.05. We have this number. Means the critical region should be T smaller than the negative this number, and T greater than the positive this number. It's our critical region. That's it. That's step 3, right? We need to compute the t-scores. How to compute the t-scores? Let's use this formula. Okay, means we need to compute M1, M2, and SM1 minus M2. We don't know any of them. We need to do the computation. So it's just simply compute. So here, I use the Excel to do it to save time. I have all the information typed in, right? So let's compute the M first, means the mean. We sum of them and then divide by n. Okay, so here we know M1 equals to, let's use 1 decimal place. Here, as M1 minus M2, we don't know yet. Let's check the formula, how to compute it. So we need to use this formula, the pooled variance. And then, how to compute the pooled variance. So, back to this formula. The SP square means the pooled variance. How to compute the pooled variance, right? Means we need to compute the SS1 and SS2 first. So go back to check the formula. SS1 and SS2, the computational formula. Here. We need to use this computational formula, means we need to know the x square and the square of sigma x. So we need to compute SS1 and then SS2. How to compute it? Let's compute s squared first. Equals to, write this number times itself. So I have all of the s squared computed, just to save time. n equal to 4. And then degree of freedom is 3, 4, and 3. And then which is sigma x squared equals to the sum of across of these scores. And then the sigma x, right, and its square is equal to the sum of the scores times itself. So the SS1 equals to this number minus this number, sigma x squared minus this number divided by n, which is 8.8. And also we can similarly we can compute the SS2 sigma 10. So we know the SS2 equals to 26.8. So let's put these numbers right back to this formula. EF1 equals 3, EF2 also equals to 3. So use a calculator to solve it. Use my calculator to solve. Then I know which is 5.9. Okay, so we know this number. Let's put back to this formula. At 9 divided by 4. Also 5.9 divided by 4. It's time to use a calculator again to solve it. We know this one equals to 1.7. We know this one. Put back to the formula. Do the computation. Equals to this one minus this one. Parentheses. Y by S, which is to 1.5. So we finished our step 3. That's the step 4, right? To make the decision. So T is equal to 0.5, which is not located in the critical region. Between these two boundaries means it's not in the critical region. So we fail to reject H0. That's it. Means we don't have significant treatment effect. And then I'd also ask you to compute the cohens D, right? R square and the square. Use the formulas. Minus 21.3 divided by the square root of pooled variance, which is 5.9. And do the computation. So minus this one divided by the square root of pooled variance, which equals to 1. Okay. 0.0. Finish. And then compute the R square. Use the formula. T-score. Last degree of freedom, which is 6. So we have x equal to 0.3. So next question. A 5 confidence interval. 5% confidence interval. Still use the formula. T 1.5 times so this one equals to this one minus this one minus T times P and T times S. So this one equals to this one minus this one plus this number, so which equals to 0 and 5. So we solve this question. And then let's write a sentence, right, to report the result. So what's the question? So here, let's go back to question and try to make it smaller, easier to read. Okay. Even smaller. Okay. Too small. Do this one. Okay. Let's try to write the sentence to report our result. So this is our question. In participants in the exercise reported our decision is we failed to reject the H0. So they reported similar strike length. That's what we measured. And then we report the mean. And then we also need to report the SD. So how to compute the SD, right? Here we also need to compute the SD. The SD equals the SS divided by degree of freedom. It's the variance, but we need to take the square root of it. SQRT. 1.7 compared to the control group, right? Also report mean and SD. Which one is equals to 3.0. Then we need to report the T degree of freedom, which is 6, equals to what's our answer? T equals to 1.5 because it's not in the critical region, so P greater than 0.05. And then we report the cohesive equals to 1.0. R squared equals to 0.03. Last one is the confidence interval of mu1 minus mu2. Equals to 0 and 5. That's it. So we solved the question 1. And then similarly, let's start question 2, right? Because the only difference is question 2 is a one-tailed test. So we just need to revise a little bit. What? Step 1, right? So because we assume a significant improvement in the scores in the exercise group, so the alternative hypothesis should be mu1 minus mu2 greater than 0. So means the non-hypothesis is not greater, means it's will be smaller or equals to 0. Okay, so the critical region is a one-tailed test. So because we assume it's an improvement in the score, so it's on the right hand side of the distribution. And then go back to the t value, t table. One sample t equals to 0.05, 6. So we have this number. Where's my number? So we define the critical region, and then step 3, we don't need to do the computation again. I'd like to see what's your t value equals to 0.1. or 1.5. Step 4, decision, because t is smaller than this number, means we fail to reject h0. We fail to reject the h0 again. And we don't need to compute, right? We don't need to compute the samples, the effect size. Let's write a sentence. Most of the parts are exact same. Part is similar. So let's just did not report higher. We cut the effect size part because we don't need to compute. Okay. That's it. Because our question is whether or not there's a significant improvement, and now my answer is there's no significant improvement, right? Did not show significant improvement. It's very easy. So we finished this question 3. Last one, right? The paired t-test. Here, we have one sample of college students. And then each student, we have 2 treatment conditions because we have one sample, just only one sample. We have 2 treatment conditions, right? With each subject has 2 scores. So it means we are going to use a pair test. Okay, so let's take a look at the questions. Similarly, just to identify the keywords, other parts they are the same. Similarly here, because it's a non-directional question, so let's do a 2-tailed test. Because here it's a directional question, so let's do a 1-tailed test. Okay, let's get started. 1. Four-step approach. State the hypothesis. Copy. Means the difference score equals to 0, right? Which is the non-hypothesis. So the alternative hypothesis is the D score is not equal to 0. So the D score is a difference, right, between different score between each measure, the scores in each condition for each subject into. So that's it. And step 2, to determine the critical region. Here we know that alpha equals to 0.05. We know the degree of freedom equals to a -1. We have 4 scores in total, so 4 minus 1, which equals to 3. And then we know it's a 2-tailed test. It means the critical region. P table again, right? 3. 2-tailed. It's not. T smaller than the negative number and T greater than the positive number. And then step 3, let's do the computation. So for paired t-test, right, we need to compute the difference score first. Where's my Excel? Okay. Here I have all the scores typed in. Difference score, right, equals to this one minus this one. Here is the formula, how to compute the difference score. Let's do it again. All this one minus this one is 2. This one minus this one is -4. This one minus this one is -2. And then we know the difference score, right? And then we need to compute the t value. The t equals to the mean of difference score divided by the standard error of mean of the difference score. So let's compute the mean of difference score first. We have all of the difference score. Compute the mean average. Which equals to minus 1.75. And then we need to compute this one. So how to compute it? Check the formula here or here. Okay, let's do it. Use this formula. So to compute the SD, right, we need to compute the SSD. Okay. So let's go back to compute the SSD. Degrees of freedom equals to 3. Compute SSD. Where's my table? Same thing. The SSD equals to, right, also use this formula. So the square of every source of all these scores. And the sum of D, and then take the square. SS equals to this score divided by this one, divided by the minus that one, divided by n, which is 4. So we have the value. So the SS equals to 20.75. Use your calculator to solve this question. It's 2.6. We know that's D, right? And then let's do the computation. n is 4. 1.3. We need the SMD. Put 1.3 here. It's equal to this number, y by 3. To negative 1 point. That's it. We have the t value. We have a big 1. And then next step, we have the t value already. And then let's start step 4. Because t is not in the critical region, so we fail to reject 0. That's it. Same thing, we compute the Cohen's d. Ooh, Cohen's d. So the Cohen's d and d we know which is negative 175. And then as we know is 2.6 here. Do it. Okay. We need to report all Cohen's d as a positive value. Let me check whether or not I did it correctly. It's correct. So we need to report it as a positive value. That's it. R square let's just solve it. It's my Excel. Means equals to the t square y by the t square plus degree of freedom, which is 3. And then I have the answer. And then the 95% confidence interval of mu d which equals to solve it. Equals to this one minus this one. Hmm? Hmm? And then equals to this number plus, right, the t times the SMD. So we just put a smaller number, negative number first, which equals to negative from range from negative 3.52 to 0.02. Okay, have everything. Last things, write a sentence to report the results. So our sentences is students is our participant in the following night with above average sleep show, because we didn't fail to reject zero, H0, so showed similar academic performance. So yeah, compared to in following night with below average sleep. So, and then here we report MD equals to 1.5 SMD, or we just said that SD equals to 2.6. And then we report the T, right? Degree of freedom, which is 3. Value, because it's not in the critical region. And then we report the coherence D. Coherence D. R squared the 95 confidence interval That's it. Okay, we solved the question 1. So let's start to the last question. The question 2, the one-tailed test. Similar, right? Similar, just have several differences. So because our question is whether or not the reduced amount of sleep time, which is the condition 2, with the sleep time below the average, right, report the significant enhancement of score. That means we assume the different score, because we computed this way, should be, we assume this one, right, this group has higher scores in this group. So that means we assume, predict the different score was smaller than 0. So the alternative hypothesis is not smaller than 0. And then the step 2, the critical region. So it's one-tailed test. And then because it's smaller than 0, so it's a left-hand side. Go to the table, one-tailed. Step 3, you have the t-value. Step 4, t is greater than the boundary. So we fail to reject A0 again. We don't need to compute here, because I think we don't need to compute the effect size. And so the last thing is to report your results. The students who right, because our question is whether or not, let's see what's your question. With night with below average sleep did not show enhanced academic performance, right? It's above. Because we are using this one compared to this one, so we report the positive score. That's it. So we finish all of these questions. In the exam, I may give you the SS because it's very time-consuming to compute. I assume everybody know how to compute SS because most of you passed exam 1. So enjoy. Hope you can have a good score in exam 2, and also have a nice spring break. See you Monday. Bye.